Imagine drifting towards the heart of a galaxy, towards the supermassive black hole lurking there, millions or even billions of times the mass of our Sun. Surprisingly, falling into one might initially be less violent than falling into a smaller, stellar mass black hole. Because they are so enormous, the curvature at their event horizon is actually gentler. The difference in gravitational pull that stretches things apart are much weaker at the boundary. You could, theoretically, cross the event horizon of a supermassive black hole without immediately being torn limb from limb, perhaps surviving for quite some time as you fall deeper inside. But survival across the horizon doesn't mean escape. Once inside, the laws of physics as we know them still dictate an inevitable plunge towards the central singularity. Escape seems impossible. Unless, could human ingenuity in the form of science fiction's favorite cheat code, the warp drive, offer a way out? Could you ride a bubble of manipulated space-time back across the point of no return? First, let's quickly recap the warp drive concept, like the Alcubierre drive. It's not about brute force propulsion breaking the speed of light locally. That's forbidden for anything with mass. Instead, it proposes warping space-time itself, creating a disturbance that violently contracts space in front of your ship and rapidly expands it behind. The ship sits in a relatively flat bubble between these distortions, carried along potentially faster than light relative to the outside universe. It's a clever workaround on paper. However, the physics required is extreme. To achieve this distortion, you'd need vast quantities of a, quote, material with negative mass, or, more precisely, a negative energy density. It has stability problems in theory, and we have absolutely no idea if it can actually exist or be manipulated. So warp drives are deeply speculative from the outset. But let's push past that enormous hurdle. Assume you have a working warp drive on your ship as you drift across the event horizon of that supermassive black hole. You're inside. Now what? The challenge is immense. Inside the horizon, space-time isn't just curved, it's dynamically collapsing inwards. The direction towards the singularity effectively becomes the future time direction. All paths lead inexorably forward in this new time, towards r equals 0. Can your warp drive fight this? The hopeful argument is that the drive's ability to locally expand and contract space-time might be powerful enough to create an outward motion for the bubble that overcomes the inward flow of the background space-time. If it can warp space more extremely than the black hole is warping it locally, perhaps it could push outwards. But the counter-arguments are formidable. First, the exotic matter problem again. Could you generate or sustain the required negative energy density inside the black hole? How would it interact with the intense gravity, radiation, and infalling normal matter within the horizon? Second, the fundamental nature of space-time inside. Does the concept of pushing outwards even make sense when the radial direction is time? The warp drive manipulates spatial geometry. Trying to force motion against the decreasing r coordinate inside might be akin to trying to force your ship locally into the past, something the drive isn't designed for and likely prohibited by causality. The very rules of the game have changed inside the horizon. Third, energy requirements. We already suspect warp drives need staggering amounts of energy, or negative energy. Counteracting the immense gravitational field and space-time flow inside even a supermassive black hole would likely require energy densities far beyond anything conceivable, perhaps exceeding the entire mass energy of stars or galaxies, focused into the drive mechanism. Fourth, stability and curvature. As you fall deeper, the space-time curvature increases dramatically towards the singularity. Could the warp bubble maintain its precise configuration under such rapidly changing and strengthening curvature? Could the exotic matter remain stable? Finally, quantum gravity. Near the singularity, general relativity breaks down anyway, and quantum gravity effects dominate. We have no reliable theory of quantum gravity yet, so we simply don't know how space-time behaves at that level, or how a hypothetical warp field would interact with it. So considering all this, can you escape a supermassive black hole with a warp drive even if you survive the initial crossing? While it remains a fantastic idea to explore in fiction, the answer from theoretical physics, even allowing for the possibility of warp drives themselves, leans very strongly towards no. The fundamental change in spacetime's nature inside the event horizon, combined with the extreme energy requirements and the instability issues in such an environment, present obstacles that seem insurmountable based on our current understanding of the universe's laws. The black hole, it seems, holds on to its secrets and its prisoners. Let me know your thoughts in the comments below. Subscribe for more explorations into science and philosophy. Thanks for watching, and see you in the next one.